Isn't it kind of wild how your phone just seems to know what you're going to type next? Or how your favorite streaming service just happens to recommend a movie you actually end up loving? Well, I promise you, it's not magic. It's all about using data from the past to predict the future. So let's pull back the curtain and see exactly how it works. Yeah, think about your spam filter for a second. That thing is a perfect example. It's constantly looking at emails and making a really smart guess. Is this junk or is it something you need to see? This is just one of a million predictions happening all around us every single day. And it all boils down to two really powerful, but actually pretty simple ideas. All right, so we're going to dive into what's called regression analysis. Now, I know that sounds super technical, but just think of yourself as a detective. You're looking for clues in the data to solve a mystery. And that mystery is always, what's going to happen next? You see dark clouds rolling in, you predict it's probably going to rain. That's basically regression in a nutshell. And what's really cool is that we can use these clues to answer two totally different kinds of questions. Sometimes we want to predict a specific number, like what's a stock price going to be? Other times, we just want to know which box something fits into, like is this email spam or not? And we're about to look at the two perfect tools for these two very different jobs. Okay, first up, let's talk about the tool that is an absolute master at answering one very specific question: how much? This is the world of linear regression. It's incredibly powerful, but, and this is a big but, it's not the right tool for every single job, as we're about to find out. So let's put you in the driver's seat for a second. Imagine you're a real estate agent. You've got data on all the houses that sold in a neighborhood last year. You know how big they were and their final sale price. Now, your job is to answer that classic how much question. How much is this new house on the market actually worth? And this is exactly what linear regression was born to do. It's designed to predict a continuous numerical outcome. Now, the key word there, and I really want you to lock this in, is continuous. We're not talking about just a few options here. We're talking about a whole range of possibilities, like price or weight or temperature. So how in the world does it work? Well, it's actually pretty intuitive. First, you just throw all your data, all those houses and prices, onto a graph. Then the model draws one single straight line that gets as close as it possibly can to all those different data points. It's kind of like finding the perfect average relationship. And boom, you've got yourself a prediction machine. Just find a house's size on the bottom, go up to the line, and see what price it spits out. Simple, right? Okay, so linear regression is awesome for predicting prices. We get it. Fantastic. But what happens when our question isn't how much? What happens when the answer isn't a number on a long ruler? What happens when a straight line just won't cut it? I mean, think about it. Predicting a house price? That's like picking a point on a ruler. It could be pretty much anywhere. But predicting if an email is spam? That's more like a coin flip. It's heads or tails. It's a yes or a no. And if you try to draw one straight line through a bunch of yeses and nos, you end up with some really weird, not so helpful answers. And this is exactly where our trusty straight line model just, well, it falls apart. If the model spits out a prediction of 0.62, what do you even do with that? Is the email kind of spammy? We need something way clearer than that, which is why we need a completely different tool. So let's bring in our second tool, Logistic Regression. Think of this one like a high-tech sorting machine. It takes all your data and just expertly sorts it into two clean piles, a yes pile and a no pile. This is the hero we need for our spam filter problem. And here's the genius part. This is the big shift in thinking. Instead of giving you a single weird number, logistic regression gives you a probability. It gives you the odds. It'll tell you, hey, there's a 93% chance this email is spam, or there's only a 10% chance this customer's going to leave. And that is information you can actually use to make a decision. Let's make this super simple. Say we're trying to teach a computer to identify a cat. The model looks at the features, the clues. Does it have 4 legs, whiskers, claws? And based on the patterns it learns from all the examples we show it, it calculates the probability for that last column. Is it a cat? Yes or no? Okay, but how does it actually do that, right? How does it take all that info about legs and whiskers and claws and magically turn it into a nice, clean probability? Well, the answer is this really, really cool mathematical trick. It's called the sigmoid function. And this, my friends, is the absolute secret sauce that makes logistic regression work. And it's really just called sigmoid because, well, it's shaped like the letter S. Imagine a funnel. That's really all this thing is. Its only job is to take any number you give it. Doesn't matter how big or small, positive or negative, and it squishes it down so that it always comes out as a value between 0 and 1. And voila, that's our probability. A number close to 1 means very likely, and a number close to 0 means very unlikely. And this right here just shows the magic perfectly. On the left, you've got the chaotic output from a linear model. I mean, numbers are all over the map. But on the right, after you push them through that sigmoid funnel, you get these perfect, easy-to-understand probabilities. That messy -10 becomes a tiny, tiny chance, and that huge 100 becomes pretty much a sure thing. And that is how we get our answer. No more confusing 0.62. Now we get a crystal clear, actionable prediction. There's a 93.2% probability this email is spam. And now we know exactly what to do with it. Send it straight to junk. So, let's put a bow on this. When you boil it all down, it's this simple. Linear regression, it's the straight line for how much questions. Logistic regression, that's the S-curve for which one questions. Two totally different tools for two totally different kinds of problems. So next time you see some kind of prediction out in the wild, just ask yourself, is this a how much problem or a which one problem? Because now you know the difference. So what about your world? What predictions are just out there waiting for you to make?